Hello and welcome. In this video we're going to be looking at the June 2018 AQA GCSE Maths Higher Paper 2. We're going to be looking at question numbers 1 through to 10 and they total 23 marks. There is a link in the description below so you can download your own copy of the paper along with the mark scheme. The video has been broken down into chapters for each question. The timestamp for these can be found in the description too, so you can easily navigate from one question to another. You may prefer to look at a question, pause the video, attempt the question and then play the video to see how you got on with it. I hope you're ready to begin, so let's get started. Question number 1. Here is a circle. Circle the word that describes the shaded part. So this shaded part here is known as a segment. We might as well go through some of the other words. So a chord is a line that goes from one end of the circle to the other end but doesn't pass through the middle. That's a chord. If it passed through the middle, then it would be called a diameter. A sector looks like this. So there is a sector, and the arc is this part here. Question 2. Circle the number that is in standard form. So for a number to be in standard form, it must be written in the form of a times 10 to the power of n, where a is somewhere between 1 and 10, and n is an integer. An integer is just a whole number. So we don't have a whole number here, so that's gone. 0.25 is not between 1 and 10, so that's gone. 38 is not between 1 and 10, so that's gone. So that just leaves us with this one here, 6 times 10 to the power of 7. Question number 3. Y is 1.5 times x. Circle the equation that is circle the ratio that is equivalent to y to x. So y is equal to 1.5 times x. So what we want to do here is we can write this as a fraction. So y divided by x is 1.5. Now 1.5 as a top-heavy fraction, an improper fraction, is 3 over 2. So what we have is y divided by x is the same as 3 divided by 2. Now the question is, what's the ratio of y to x? Well, if y divided by x is the same as 3 divided by 2, then the ratio of y to x is 3 to 2, because we've got a y on the top, so we'll have a 3 where the y is, and then divided by x, and here we're divided by 2. So the ratio would be 3 to 2. So this one here. Question number 4. Work out 40 as a percentage of 10. Circle your answers. So we're going to write 40 as a percentage of 10. So the first thing I'm going to do is write 40 as a fraction of 10. So to write a number as a fraction of another, you write them on top of each other. So 40 as a fraction of 10 would be 40 over 10. And now I want to convert this into a percentage. So to convert a fraction to a percentage, we're going to multiply it by 100. So 40 divided by 10 is 4, and I'm going to multiply that by 100, which gives us 400%. So this option here. Question 5. Match each sequence to its description. The first one has been done for you. So we've got a bunch of sequences on the left and a description on the right. So let's go through the ones that we can recognize easiest first. So I recognize this one, 1, 4, 9, 16, 25 and 36. Those are my square numbers. And just underneath we've got 1, 8, 27, 64, 1, 2, 5, 2, 1, 6. These happen to be the cube numbers. Okay, now 1, 3, 6, 10, 15, 21. These are your triangular numbers. 1, 3, 6, 10. So these are my triangular numbers. So now we're left with this one and this one. So arithmetic and geometric. So an arithmetic progression is one which is increasing or decreasing by a fixed amount. So this one is increasing by 1. So this makes it an arithmetic progression. And a geometric progression is one which is a sequence where the numbers are multiplied or divided by the same number. So I can see here that we're multiplying through by 2 all the way. So that one makes it a geometric progression. Question number 6. The table shows information about the population of a city. So the population in 2001 is 420,000. Population in 2011 is 480,000. Liam claims that from 2011 to 2021, the population of the city will increase by the same percentage as from 2001 to 2011. So he works out the population increase from 2001 to 2011 is, we just subtract the numbers, is 60,000. So the calculation he's done is population in 2021 was 480,000, which is from 2011, and then he's added the 60,000 because that's what's gone on here. And he's got 540,000. Does the population of 540,000 match his claim? I must show you working it. Okay. So his claim is that it increases by the same percentage. So we need to work out the percentage change here. So the formula for percentage change is change divided by original times 100. So let's work out the percentage change from 2001 up to 2011. Right, so the change from 2001 to 2011, well, it's increased by 60,000. So our change is 60,000 divided by our original value, which is 420,000. And then we times that by 100. Let's type this in. And this gives us as a percentage 14.3%. So from 2001 to 2011, we have had a 14.3% increase. Now, based on the calculations here, let's look at the percentage change from 2011 through to 2021. So if the population is now 540,000, then the difference between them is still 60,000. Our original value, though, is now 480,000. And then we're going to times that by 100. Let's type this in. I'm just going to change that into 480,000. Everything else is the same. And that gives me 12.5%. So it's an increase of 12.5%. Now Liam claims that the population will increase by the same percentage, but we can clearly see that it's increased by 14.3% here and 12.5% here. So does the population of 540,000 match his claim? No. Okay, so no, we do not increase by the same percentage. Question 7. On 3 days, Ali throws darts at a target. Here are the results. We've got Monday, Tuesday, Wednesday, the total, and then we've got the number of throws, the number of hits, and the number of misses. 7 part A. Work out 2 different estimates for the probability of Ali hitting the target. Okay, so one probability of him hitting the target. Well, how many times does he hit the target in total? 54. Out of how many throws? 90. So 54 over 90 is one estimate. Another estimate could be just on Monday, or just Tuesday, or just Wednesday. So the Monday date, the numbers on Monday look a lot simpler to work with. So let's go with Monday. So what's the probability of hitting the target on Monday? Well, that's 15 hits out of 20 throws. Okay, so work out 2 different estimates. Now, you can give these estimates as fractions, decimals, or percentages. I'm just going to simplify these fractions. So 27 over 45, which is 9 over 15 divided by 3, is 3/5. So 3/5 is 0.6 or 60%. 15 over 20, both divide by 5, so we get 3/4, which is 0.75, which is 75%. So work out 2 different estimates for the probability of Ali hitting the target. Okay, so there's my 2 estimates, 60% and 75%. Which of your 2 answers is the better estimate of Ali hitting the target? Give a reason for your answer. Now, what you're looking for is the one which has the most trials, because the more trials you do, the more accurate your answer. So the answer I'm going to go with is 54 out of 90, because this is based on 54 hits out of 90 attempts compared to 15 hits out of 20. So I feel this one is going to be more accurate. 54 over 90, or you can put 60% if you prefer. Okay. Reason, more trials lead to more accurate results. Question number 8. Theo starts with savings of £18. James starts with no savings. Each week from now, Theo will save £4.50 and James will save £4. In how many weeks will Theo and James have savings in the ratio of 15 to 8? Right, so let's write down some information. So we've got Theo, let's call Theo T, and James we'll call just J. So Theo has £18, and then every week he is going to save £4.50. So I'm going to write 4.5 times the number of weeks, which I'm going to call x. So let x equal the number of weeks. So if I want to know how much Theo has after 4 weeks, then I'll just substitute x equals 4. A similar equation for James. He starts with no savings, so it's going to be 0 plus 4 times the number of weeks. Okay, so Theo has, the equation for Theo is 18 plus 4.5x, and for James is just 4x. And I want to know when the ratio of Theo and James, ratio of Theo to James is equal to 15 to 8. So what we're going to do is we're going to do something very similar to what we did in question 3. So the ratio of Theo to James, I'm going to write as Theo divided by James. And if I want this to equal this, if I want this to be the same ratio as 15 to 8, then this needs to equal 15 to 8. Okay, so the T's on top, so the 15 is on top. The j is on the bottom, so the 8 is on the bottom. So I'm going to substitute the equation with Theo here and James here. So we have 18 plus 4.5x divided by James, who is 4x, and that's equal to 15 divided by 8. Now we have a fraction equal to another fraction, so what we can do is cross multiplication. The top of the left multiplied by the bottom of the right is equal to the bottom of the left multiplied by the top of the right. So let's do this times this. Let's move over here. So let me leave it in brackets for now. So 8 times 18 plus 4.5x is equal to 15 multiplied by 4x. So 8 times 18, so 18 times 8 is, so if we double it, it's 36, double again is 72, double again is 144. 4.5x times 8, so if we double it, it's 9, double again is 18, double again is 36. This is a calculator paper, so you can use a calculator if you need. And 15 times 4 is 60x. So now we just go and solve this. So I'm going to minus the 36x from both sides. So 144 is equal to 60x minus 36x. So 144 is 24x, which means that x is equal to 144 divided by 24. And if I simplify this, 72 over 12, they are both even, so I can divide by 2 again. And 36 divided by 6 I know is 6. So the answer is x is equal to 6. So in how many weeks will Theo and James have their savings in the ratio of 15 to 8? 6 weeks. Question 9. The length of each side on a regular pentagon is 8.4 centimeters to 1 decimal place. Complete the error interval for the length of one side. So this question is on error intervals. So the number we are given is 8.4. This is measured to 1 decimal place. So the value above it would have to be 8.5 and the value below it would be 8.3. So the lower bound is going to be the number halfway between these two, which will be 8.35. The upper bound will be halfway between these two, which is 8.45. And then we put in our inequalities. X there. So let's copy that in. So 8.35 is our lower bound, and 8.45 is our upper bound. 9b, complete the error interval for the perimeter for 1 mark. So the key thing here is it's a regular pentagon, which means that all 5 sides are equal. So the lower bound will be 8.35 multiplied by 5, and the upper bound will be 8.45 multiplied by 5. Let's type this in. 8.35 times 5. 41.75, and then 8.45 times 5. 42.25. And that's it. Question 10. The volume of a sphere is equal to 4/3 pi r cubed, where r is the radius. A container is a hemisphere of radius 30 centimeters. So I'm just going to mark the radius on here. The radius is 30. Sand fills a container at a rate of 4,000 centimeters cubed per minute. Does it take less than a quarter of an hour to fill the container? You must show your working out. So I'm going to start off by working out the volume of the sphere. So that's 4/3 pi r cubed. So that's 4 divided by 3 times pi times 30 cubed. Let's type that in. So that's 4 over 3 times pi times 30 cubed. I'm going to leave that in terms of pi for now. 36,000 pi. 36,000 pi. Now, the question is about a hemisphere. So the volume of the hemisphere, well, the hemisphere is half of a sphere. So its volume will be half of the volume of the sphere. So it'll be half times 36,000 pi, which is 18,000 pi. So the volume of the hemisphere is 18,000 pi. What's 18,000 pi as a decimal? So let's times this by a half. So that's 18,000 pi, and as a decimal we have 56549 to the nearest whole number, and that's centimeters cubed. Now, sand fills the container at a rate of 4,000 centimeters cubed per minute. So how long will this take? The time it's going to take will be 56,000, because that's the whole volume, divided by the amount that we fill every minute, so 4,000. So I'm going to do this calculation now. Remember to use the full answer from here, don't just type in that number. So I've got the answer there, so all I'm going to do is divide that by 4,000. And that gives me 14.13. Now, what are my units for this? Well, the 4,000 is per minute, so this is going to take me 14.13 minutes to fill the container. The question says, does it take less than a quarter of an hour to fill the container? And your answer is yes. It takes 14.13 minutes. Thank you for watching our video. I hope you found it useful. If so, please hit the like button, which helps the YouTube algorithm find other students who we may be able to help. Please let me know in the comments what you think about it, and if you have any further questions, feel free to type them in there. For more content like this, remember to hit the subscribe button. See you next time.